students, welcome to the another session. And today we will be discussing about the concepts of a simple and easy topic of application of derivatives. It's a part of the application of derivatives, and that subtopic is called tangents and normals. What is meant by a tangent to a curve, and what is the normal? How to find out the things? See, first of all, what is the derivative gives us? What is the derivative gives us? So f dash of x is simply limit delta x tending to 0 f of x plus delta x minus f of x by x plus delta x minus x. So what is that? If you have a curve like this point is on x coordinate, if this is x, and there is a point at a distance of delta x, so this point will be x plus delta x. So you join this. So if you look for the slope of this line, this corresponding y value is f of x plus delta x. The corresponding this value, y value is f of x. So the slope of PQ is equal to f of x plus delta x minus f of x by delta x. If this delta x is 0, means approaching closer to this one, this this chord becomes a tangent. So this delta x may be this side or this one. So these are the things. So you are going to get a tangent here. So simply f dash of x naught is the slope of tangent at x naught to the curve y is equal to f of x. So if this line is making an angle of theta, this is called the inclination, and also I can say f dash of x naught is equal to tan theta. Okay. Now, what is meant by a normal? For any curve, y is equal to f of x. Any curve y is equal to f of x. Let us say this is a tangent touching at this point. This point is called the point of contact. A line perpendicular to the tangent passing through the point of contact. This is called the tangent. This is called the normal. So if this is the curve y is equal to f of x, this point P is x1, y1, and this curve is y is equal to f of x. So straight away I can write what is the slope of tangent is f dash of x1. Okay, so tangent equation is y minus y1 because I have the point, I know the slope in this form is equal to m into x minus x1, and the normal equation is y minus y1 is equal to minus 1 by m into x minus x1. It makes a lot of things because particularly in the differential equations, we use a lot about this. And here, sometimes what happens, no, they'll talk about the x-intercept, y-intercept. In any line, if I want to find x-intercept, substitute y is equal to 0. Okay. In any equation, if they are talking uh, x-intercept. So what you need to write? Y is equal to 0. To find the x-intercept, we need to take y is equal to 0. To take y-intercept, you need to take x is equal to 0. Because in the differential equation, when they are giving, they'll talk about the tangent x-intercept, y-intercept and everything. So tangent and normal mutually perpendicular. Okay. Next one is tangent to a curve at point P x1 y can be drawn even though dy by dx at P does not exist. That means dy by dx does not exist means you may get like dy by dx is equal to something by 0 means if you have a curve like this. So what is dy by dx? For example, x square plus y square is equal to 25. What is the tangent at x is equal to 5? So at this time, you have a circle and at x is equal to 5, this is the tangent is parallel to y-axis. So when the tangent is parallel to y-axis, dy by dx does not exist. If the tangent at any point on the curve equally inclined to the both the axes, so equally inclined to the both the axes means 45, 45. Here the slope is equal to minus 1. Here 45, here 45. Slope is equal to 1. So here x-intercept is equal to y-intercept. So either intercepts in magnitude-wise way same are equally inclined to the coordinate axis. Dy by dx will be equal to plus or minus 1. If the tangent at any point makes intercepts, equal intercepts. So equal intercept means here clearly yeah, both are positive intercepts or both are negative intercepts. You cannot take that equal intercepts as this one. This is 1, this is minus 1. They are magnitude wise equal, but equal, not equal intercepts. Here x-intercept is minus 1. You cannot say x-intercept is 1. So it is not. So equal intercept means both are positive or both are negative. So here A, so slope will be equal to minus 1. And this second part is very important. A general second degree equation, we typically we write S is equal to ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. If x1, y1 is a point on this curve, x1, y1 is point on this curve, we will be getting S11 is equal to 0. Typically, you know this notation. What is S11? That is ax1 square plus 2hx1y1 plus by1 square plus 2gx1 plus 2fy1 plus c. This value has to be 0. In that situation, the tangent equation is S1 is equal to 0. What is this S1? They mention something here. Okay. So instead of that one, I'll write. In this ax square, there are the two sets of x are the x into x. So let me write axxx plus 2hxy. I will write here hxy plus hxy plus by square. I will write b into y plus g into x plus x plus f into y plus y plus c is equal to 0. Now, if I want to find the tangent, what I'll simply do, the one set of x comma y, one set of x comma y, I'll make it as constant this. So what I'll write, this one is 1, axx1, hxy. Here I'll make it as constant and here y I'll make it as constant. And here y, here x, here y will be this one. So the equation will become axx1 plus h into xy1 plus x1y plus byy1 plus g into x plus x1 plus f into y plus y1 plus c is equal to 0. This is the tangent. This is the tangent. Now, with the help of this one only, we write the tangent. Circle equation is x square plus y square plus 2gx plus 2fy plus c is equal to 0. This is the circle equation. Parabola S is y square minus 4ax is equal to 0. Ellipse x square by a square plus y square by b square minus 1 is equal to 0. Hyperbola x square by a square minus y square by b square minus 1 is equal to 0. In all these cases, the tangent equation is standard S1 is equal to 0. S1 is equal to 0. So in this case, what is S1? Xx1 plus yy1 plus g into x plus x1 plus f into y plus y1 plus c is equal to 0. In this case, yy1 minus 2a into x plus x1 is equal to 0. In this case, xx1 by a square plus yy1 by b square minus 1 is equal to 0. In this case, xx1 by a square minus yy1 by b square minus 1 is equal to 0. We have the normals and etc. Those things we'll discuss with the anyway circles and conic section. Now you look at this one, this diagram. A curve is given to us. A curve is given. Y is equal to f of x. The tangent is drawn at P. Tangent is drawn at P. So where the tangent from P meets the x-axis, that is called the length of the tangent. So here this point is P. Tangent at P meets the coordinate axis at T. So PT is called length of tangent. Pn is called a length of normal. Now, the projection of tangent on x-axis, This portion is called length of subtangent. Projection of normal on x-axis, length of subnormal. Okay. So you take the same triangle here and complete the sum of the formalities. What are the formulas we are supposed to derive? So this tangent is making an angle of theta. So clearly a tan theta is equal to f dash of x. So this point is x comma y. So this length is equal to y. So you take the triangle P T N M. So PTM, from PTM, tan theta is equal to PM by TM. So TM is equal to PM by tan theta. So which is equal to Y by, if I write this one, okay, F dash of X. If I take sin theta, because I need these two only. So sin theta is equal to PM by PT. So PT is equal to Y by sin theta. For example, tan theta is equal to F dash of X. Okay. So right angle triangle. This is theta. This is F dash of X. This is 1 because tan theta. So this value will be 1 plus F dash of X whole square. So you are going to get this is Y into root over 1 plus F dash of X whole square by F dash of X. Similarly, you can find this is theta, this is 90 minus theta. So with that help of that, you will be getting these key points. Please make a note of these key points. If x comma y be a point on the curve tangent normal to the meets x and y axis at Tn, dy by dx m is equal to length of the tangent, length of the normal, length of subtangent, length of subnormal. You look at here, length of subtangent into length of subnormal is always equal to y square. Okay, is always equal to y square. Okay, so at any point x1, y1, you're drawing the tangent, then it's subtangent length, product of subtangent and product of subnormal. Product of subtangent length and subnormal length is always equal to y square. Next one is area of the triangle formed by tangents and normals at the point P x1, y1 on the curve. Y is equal to f of x is. So, the curve is like this. Your tangent and this is the normal. They are asking area of the triangle formed by tangent, normal on the curve and the x-axis is. So this point is x1, y1. So this length is equal to y1. Okay. So m is the slope of the tangent. What is the area? So tangent equation is y minus y1 is equal to m into x minus x1. So this is the x-axis. So I need to find out x-intercept. Substitute y is equal to 0. Okay. Substitute y is equal. Or simply what happened? This is right angle. Area will be equal to this length into this length. PT into PN. Area is equal to half of PT into PN. So which is equal to half into PT is this one P. So what is this one? Half into y square into 1 plus m square by m. Okay. So this is the area of the triangle formed by tangent and normal and x-axis. Another important point is angle between two curves. So y is equal to f of x is this is one curve and you have the another curve y is equal to g of x. If these two are intersecting at x1 y1, so y1 is equal to f of x1, y1 is equal to g of x1. If this is the point intersecting, what is the angle between these two curves? So angle between these two curves means it is simply angle between, so this is the tangent to the first curve. So m is equal to m1 is equal to f dash of x1 and this is the tangent to the second curve y2 m2 is equal to f dash of x2. So angle between the tangents is defined as the angle between two curves. It is simply angle between their tangents at the point of intersection. So the two curves are intersecting. Now, for example, a curve is there and line is there. What is the angle between? So this line is line as it is, but for curve you need to draw the tangent. Now, if this is the curve here, you have a curve here. So this angle between the curves at this point need not be same as angle between these curves. So M2, sorry, here G dash of X1. If M1, M2 is equal to -1, angle between the tangents is 90 degrees and we'll say curves are orthogonal. Curves are orthogonal. Okay. So whenever you want to find the angle between two curves, first thing you need to find the what is the point of intersection and then M1, M2 are the things. Then tan theta is equal to already you learnt in the geometry angle between two lines modulus of M1 minus M2 by 1 plus M1 M2. For example, M1 is equal to M2, curves are touching each other. For example, this is one curve, this is one curve. So what will happen? They have the common tangent. So the curves are touching. The curves are touching. Okay? So quickly recap of this tangents and normals, which is very simple concept. Okay. So what is the definition of the tangent? What is the definition of normal? Okay. So what is the slope of the tangent? Which is nothing but f dash of x1. How to write the normal equation, tangent equation? Y minus y1 is equal to m into x minus x1 is the tangent. Y minus y1 is equal to minus 1 by m into x minus x1 is the normal. What is the length of the tangent? Length of the normal length of subtangent, length of subnormal, and then angle between two curves. Angle between two curves. So these are the points in this chapter. Okay. Have a look at these points once again, and very important chapter as per differential equations is concerned. Okay. Thank you. See you with another session, another topic.